Hi, on this session we are going to have a quick look at what do we mean by heteroskedastic errors. So if you have not had a look at the homoskedastic errors, I would encourage you to have a quick look at that video before we go through the heteroskedastic errors. So basically, when we talk about heteroskedasticity, again we are talking about the error terms. Now in a linear regression model, if the variance of the error terms, in other words, the variance of the conditional distribution of u given x, if it depends on x, then the error term is called heteroskedastic. So simply what that means is, if you see, so that's the population regression line, which normally in practice we will not have, but I'm just using this to try and explain the concept. So let's assume that this is the population regression line, and every time we select a random sample, we will have different x values, in this case different salaries, and for each individual salary we will have a corresponding saving. So for example, if your salary is, let's assume these are in thousands, so if your salary is 30,000, you're somewhere here, and based on the sample your savings could be somewhere in this line here. It could be more than the population regression line, or it could be less than the population regression line, but it could move somewhere here based on the random sample you select. So the difference between what the population regression line says and what your sample data says, that will the difference will be the error term, and the error term itself will have a spread if we have quite a lot of samples. So that's what we are showing here. Now the spread of the error term and the variance of the error term, that's what we are talking about here. The variance of the conditional distribution of u, which is the error term. The variance of the error term, you can see it's not the same. It keeps increasing as the value of x increases. In other words, as your independent variable, the value of your independent variable increases, the variance of your error term keeps increasing. Now in this case, the error terms are called heteroskedastic. So the special case of heteroskedastic is, which we discussed before, which is homoskedastic, where the error terms are constant. The variance of the error terms are constant for a given value of x. In other words, the variance of the error term does not depend on the value of x. Then we have a special case, a special term, which we say the error terms are homoskedastic. But in most practical scenarios, the error terms in a linear regression will be heteroskedastic. So the issue with heteroskedastic is that when the errors are heteroskedastic, the least square assumptions, which we have listed here, these least square assumptions are not violated, whether the errors are heteroskedastic or homoskedastic. So that's what we are saying here. The OLS estimator remains unbiased, consistent, and asymptotically normal, even if the errors are homoskedastic or heteroskedastic. So whether the error terms are heteroskedastic or homoskedastic does not violate these least square assumptions. Now mainly this is because if you look at the first least square assumption, it talks about the conditional mean of the error term for a given value of x is 0. In other words, it's dealing with the mean of the error term, not the variance of the error term. Now due to that, because remember, homoskedasticity and heteroskedasticity deals with the variance of the error term. Now the least square assumption, the first least square assumption, deals with the conditional mean of the error term, not the variance. But the issue is that if the errors are heteroskedastic, the OLS estimator is no longer blue. In other words, the OLS estimator is no longer the efficient estimator. Now another important thing to remember is, even if the errors are heteroskedastic, like here you can see the spread keeps changing as the value of x changes. Even if the errors are heteroskedastic, the OLS estimator still remains unbiased. So that's something to remember. It still remains unbiased, but it's no longer efficient. It's no longer blue. And also in another video we will discuss, when the errors are heteroskedastic, the standard errors you should be using are different from the standard errors that you will be using when the errors are homoskedastic. So we will discuss that in another video. So remember, it's important to know whether your errors are homoskedastic or heteroskedastic. Now that's because it becomes important when we try to compute the standard errors of the estimators, which we will discuss in another video. Thank you.